Thanks for everybody for coming. My name is Sam Sherraden. I'm a CBS graduate from 2014. We're very excited to hear from Daniel Guetta. He's going to speak to us on pulling back the curtain on deep learning, neural networks, and generative AI. Professor Guetta is an associate professor of professional practice here at Columbia Business School. He received his PhD from Columbia in 2015. He spent time at Palantir Technologies, and his research focuses on how data and analytics can drive value for firms. Professor Guetta, we're all extremely excited to hear from you on this prescient topic. Take it away.
Thank you so much. Thank you so much. I'm so pleased to be here with everyone. I hope none of you are expecting David Guetta. There's a confusion sometimes, but I know he played, was it last Friday night here? But you'll get me. Would you say? To play some music? Maybe at the end. We'll see. We'll see. So excited to be here with all of you for many reasons. One of the reasons is, as sort of Sam kindly mentioned, I did my PhD at Columbia Business School. That's where I sort of initially began my training. And for the first time in reunion, there are some people in this room who had me as their TA back when I was at Columbia Business School. So core stats, core business analytics, and then luckily I got to teach the classes afterwards, which is super exciting. Things have changed a little bit in the space of data science, in the space of stats, the sort of advent of machine learning, Gen AI. And what I want to do today, hopefully, is I want to give you an introduction, which I have found personally is very hard to find really anywhere. Generally, when you talk about this Gen AI stuff, you have two options. Either you listen to a TED Talk or you read a New York Times article, which are fantastic, but they're very high level. You kind of get a rough idea of how it works, but what's actually going on inside, unclear. That's one end of the spectrum. The other end of the spectrum, you need, a PhD in math, 5 years of, the Python, and then you eventually read the code and you read the math that actually operates these things. I want to land somewhere in between today, hopefully, which, by the way, is really where we try to land at CBS when it comes to our data and analytics curriculum. A lot of our classes try to land it in between, where we really give you the kind of knowledge you need to understand what's going on under the hood, to implement those models well, but, doesn't put you to sleep with math, hopefully. We'll see how many people are sleeping by the end of, in 45 minutes, and we'll see if I was successful. Okay, so that's generally the plan for today. And why did I pick this topic? I mean, not particularly, I don't think I need to convince anyone about what a big deal Gen AI is today. I'm going to show you a quote that was it wasn't tweeted, it was a Facebook status, that's how old it is, at the time by Professor Dan Ariely. This was in 2013. When he said, big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they're doing it. With respect to Dan Ariely, I'm going to amend this quote a little bit. I'm going to say, Gen AI is like teenage sex. Everyone talks about it. Nobody really knows how to do it, and so on and so forth. So let's jump in and let's try and figure out how to do it, how it works, what actually happens. And the first thing I want to do is solve a sort of problem that I think really sort of permeates this field. Is just give you a little bit of history to explain what is the difference between machine learning and Gen AI and deep learning and predictive analytics, all this sort of words swirling around. Let's go through a very brief history of how all this stuff developed to try and get an idea of where we are now and how we got here. So we're going to begin way back in the 60s when people started thinking, wait a second, can we do artificial intelligence? What did they mean by artificial intelligence? They meant giving computers the ability to do tasks that traditionally only humans have been able to do. Now, if you were to do this today, you were to start artificial intelligence from scratch, what would you do? Well, if you're anything like the people at the folk in the 60s, and they were very smart people, they said, well, you know what? Let's start putting down a bunch of rules. Let's start thinking, when me as a human, let's say I decide to grab coffee downstairs, what thought process do I go through? How much sleep did I have tonight? How tired am I feeling right now? Do I prefer coffee or tea? Right? I'm going to go down this sort of list of questions implicitly in my mind, and I'm going to come up with a decision of whether to have tea or coffee. Similarly, when I'm deciding the next word to say right now, there's probably a whole bunch of stuff going on in my mind. What am I trying to communicate? What word did I just say? And so what people did initially is they literally tried to build, linguists would sit in a room and build hundreds of questions to be like, okay, well, suppose I have an adjective. What is most likely to come next? Suppose I just said a noun that sounds, right? And so on and so forth. They would sort of really try and construct these rules. And they weren't completely unsuccessful. I'm going to give you an example. The first example of this kind of artificial intelligence was called ELIZA. And ELIZA was supposed to be an artificially intelligent therapist. So it was a computer program, you'd speak to it, and it would speak back and give you therapy. So I'll give you an example of what that looks like. This is the True Eliza program, 1966 over here. Isn't this cool clicker, what I can do with it? It's kind of nice. You can zoom into the slides. I never tire of this. So let's see how Eliza does. Eliza begins by saying, is something troubling you? And then you say, men are all alike. Don't we all know it? Eliza says, what is the connection, do you suppose? You say, they're always bugging us about something or other. Can you think of a specific example? Well, my boyfriend made me come here, and so on and so forth. It just sort of, goes on in that way. Now, I think what's interesting is, number one, pretty good. I mean, it seems like it's a real conversation. Number two, we've all experienced these chatbots in our lives. This is what things were like 10, 20 years ago, right? When you sort of got a response that sort of sounded human, that seemed like it was syntactically correct, but clearly it was not a human on the other end of the computer, despite the fact there were these hundreds of thousands of rules that ran this system. What was the problem? Why didn't this really work? And there's a simple reason it didn't really work, which is that we know more than we can tell. What do I mean by that? Anyone in this room who's had the fortune of ever having therapy will know. If you're trying to figure out why you make a certain decision, that ain't easy, right? Even one single small decision, to be able to break it down into the hundreds of thousands of different choices going on in our mind, the idea that someone's going to be able to write those all down, impossible. And so that was kind of the end of that first phase of artificial intelligence. But artificial intelligence it was. What did people do next? They were like, all right, so we can't list every single rule. What else could we do? Well, let's think of babies. How do babies grow up into humans who know how to talk and walk and so on? Do we tell them every single rule of grammar? Do we tell them every single thing, if you walk forward, then you'll go forward? No, we don't tell them that. What do? We just stick them in the world and, let them learn. They kind of crawl around and then they figure out what is forward, what is backwards, how to see, and so on and so forth. And people say, well, let's do the same thing for computers. Enter the field of machine learning. What does machine learning do? It says, let's just give the computer lots of examples of inputs and outputs, and then we'll let it learn by itself, just like a baby does. Very nice. So that was the world of machine learning, extremely popular until I would say around 10, 15 years ago. By the way, still popular today. Everyone likes to talk about deep learning and yada, yada, yada. Let's be honest with each other. About like maybe 90% of all the AI in practice today is still this machine learning stuff, right? I mean, if you're applying for a credit card and the bank is going to say, yes, you can borrow, no, you can't borrow, that is going to be classical machine learning techniques. We're not talking any deep learning there yet. Okay. Now, how does this model learn, right? We said it looks at data and then sort of learns. Well, it's actually really much simpler than you would think. And that's something I really, really try to highlight in a lot of my classes. All that happens is, you have this model that's supposed to take a bunch of inputs and produce some outputs. So for example, it takes all your credit history and produces the probability you're going to default on your loan, let's say. That's a very standard AI model. Instead of a human doing it, the computer does it. How does it do it? Well, it begins as a baby model that can't really do anything, just like a real baby that sort of bumps around into walls and doesn't know how to walk around, doesn't know how to eat, doesn't know how to do anything. Then you give it some data. And then the data is going to sort of, this Oscar-winning animation here will show you that this data will go back and forth with the model and will eventually turn this model into an adult model that can actually make decisions. How does that process happen? The process of turning the baby model into an adult model? It is unbelievably simple. All that happens, and I spent about 12 hours on this in my electives here at CBS. I wish I had 12 hours with all of you. Maybe can I go for 12 hours? Is that? Okay, no, I'm hearing no from the front row. There's a lot of detail here, but the fundamental principle is super simple. All that happens is you do good computer, bad computer. You take your initial model that can't do anything, that's really sort of bad, that can't make predictions, and then you say, what if I tweak it a little bit? Does it get better or does it get worse? It gets better? Great, let me move more this way. It gets worse? Okay, I'm going to step back. And you just keep on randomly tweaking the model until you get to the best model that can really see what's happening in the world. Now, has anyone heard the fact that these AI models are very expensive to train, right? Has anyone heard that OpenAI spent billions of dollars to train something like ChatGPT? Guess what? It's because of this process. The good computer, bad computer, that takes a lot of computing power. You've got to do this billions, trillions of times to get the model good. Okay, so that's kind of the machine learning. And then finally, we get to, and I'm going to skip over a few slides here, we get to a crucial point, which is, Okay, so that's machine learning. We have artificial intelligence, machine learning. How do we get to the recent stuff, the good stuff, the deep learning, 10 years ago, the sort of main topic of what we're going to talk about today? Well, the problem with machine learning, even though it's a great tool, it works really well, it can predict whether someone's going to default, it can do all kinds of things, there's one thing it cannot do, and that is deal with unstructured data. What do I mean by unstructured data? I mean something that doesn't come in a nice table, right? You don't, in real life, you don't just get a nice Excel spreadsheet you can download that says, everything you need to know about the world. In real life, you get ugly, unstructured stuff like pictures, like sounds, like video, like whole dumps of text, right? These things you can't put in a table. And so these classical machine learning models, computers are very smart, but they can only understand numbers. If you give a computer this image and you tell it, is it a dog or is it not a dog, the computer's going to be like, what is this? What exactly am I looking at, right? And so these classical machine learning models, if you think of the last 10 years ago, 15 years ago, there was a lot of AI in the world, but it was only on very structured data. For example, an AI might guess whether you would default on a credit card. An AI might guess whether you as a consumer was about to cancel your cable contract. An AI might determine whether you are the most likely person to, respond to a certain advertisement. And so people would show you that advertisement. But this is all structured data. You would have all these columns about the person. What is their age? How many websites have they visited that year? What's their annual income? And then you would use that to make those predictions. What we couldn't do 10, 15 years ago is give it a bunch of pictures, give it a bunch of text, and hope that it would figure out what was happening. Everyone with me? To solve this, enter deep learning. The amazing thing about deep learning is that it is able to take this unstructured data and actually make sense of it. And that's what we're going to spend the rest of our time today talking about. And I want to show you some interactive examples just to show you the power of it and what it can do. Now, the question is, how does it do it? And the best way for me to describe how deep learning does it is using an example. Luckily, in this room, we have many very, very, very specialized, very highly trained neural networks in all of your heads. And so I'm going to ask for a volunteer to do a little exercise to show you a little bit of how deep learning works. Does anyone brave want to volunteer here? Don't make me cold call. Thank you ever so much. Raphael, great. So Raphael's volunteering. No, you can just sit down. It's all good. I'll just call on you from down there. Don't worry. If only I told everyone it was so easy, you could have glory without even standing up. Okay. So let me sort of explain to you a little bit of what deep learning does. I'm going to come back to this slide in a second. But let me show you a picture, Raphael. I'm going to show it to you now. Okay, just looking at the picture. And now I'm going to ask you, what did you see? One sentence. Two kids, great. And two sculptures, perfect. And now let me ask you, what time of day was this picture taken? Best guess? Sunset, right? Now, one thing, I'm going to try and switch off the lights right over the screen so that you can see better. Give me one quick sec. It should be better. Any better? I think it is better. Great. Okay, perfect. Good. So I want you to notice something about what Raphael said. He looked at this picture. When I asked him, what did you see? Did he tell me, well, the top left was pink, then a little more pink, then pink, then pink, then pink, then red, right? He didn't say that. What did he say? He looked at the picture and he extracted concepts out of it, like all of us do. He was like, oh, maybe there's two kids and there are two sculptures. And then he might have said, if I'd asked him for more, he might have said, oh, I maybe saw some sand, I saw some people in the background. Right? He extracted these general high-level ideas about the picture. Then when I asked him what time of day was it taken, he was able to draw on this library of concept that he had built to then say, oh, based on all these concepts I have in my mind, not the full picture. He hadn't memorized the full picture. If I now told him to reproduce the full picture with pen and paper, even if he was an amazing artist, he wouldn't be able to do it exactly, unless he was really a savant. But nevertheless, with the concept that he'd extracted from the picture, he was able to tell me, this is probably sunset. Everyone with me? That is exactly what deep learning does. How does it do it? Well, this is a complicated slide. It's actually quite simple. All it does is it takes classical machine learning models, not to bring back any bad memories, hopefully good memories from your core stats class when you were here at CBS, but you all did linear regression, right, when you were in stats at CBS. Happy memories, I'm sure. Imagine linear regression, but instead of one linear regression, you have something like 95 billion linear regressions. Each of these circles is a linear regression, and they all feed into each other in weird and wonderful ways. Don't worry, we're not going to go into any more detail than that, but that is effectively the level at which this happens. You have these linear regressions that keep on feeding into each other, and as they feed into each other, they start learning, aha, this is sand, this is a person, this is a dog, this is a smile, this is a curb, this is a... And then using that, it can make any conclusion you want. It can tell you what time of day was this picture taken, is this picture of a certain important thing, less important thing, etc. And that's pretty much how deep learning works. Questions? Okay. What I want to do now is probably the most exciting part of what we're going to do today. Until about 4 years ago, let's say, a lot of this was well understood and worked really well for images. So I've been only using examples as images so far, but not so much for text. The real revolution of the last 4 or 5 years has been things like ChatGPT. We're now able to do this, not with pictures, but with text. And I want to deep dive now and show you what that means when it comes to text. How do you take this high-level idea that I demoed with Raphael, and how do we actually do that with text? How do we look at a piece of text and extract some sort of concept or some sort of meaning out of it? Is everyone with me on what we're going to try and do? Okay. It turns out the key concept that is used in all the models you see today is a simple concept called embeddings. Let me explain what I mean. Suppose you have a bunch of words: man, lady, queen, being, peach, woman, king, apple, and pear. You look at all these words, and as humans, we look at these, and there are definitely some words here that have more of a relationship to each other than others, right? If I look at this, I mean, I don't know, man, being, lady, woman. Lady and woman are pretty close to each other. They're sort of synonyms, though not exactly, whereas a word like apple is totally unrelated to them, right? That sort of high-level idea that us as humans, just like Raphael when he saw the picture, we get in our minds. How does ChatGPT get it? And the answer is, it does something called an embedding. The embedding is very simple. What does it do? It says, let's take each word and let's give it 2 numbers. In reality, by the way, it's like 3,000 numbers, but I don't have 3,000 dimensions on the slide, so I'm just going to show you 2 numbers to make it sort of clear. And what those 2 numbers might be is, on one axis, how male versus female is the word. -1 is completely male, 1 is completely female. And on the y-axis, how non-human versus human is the word. And so, for example, the word man is very human and very male. King is, you know, a little less male. Maybe you could refer, it has less sort of, genderness in it. It's a little less human because you're not directly referring to the person. A word like apple is completely non-human and neither male nor female. Peach, maybe a tiny bit more female. You could refer to a really nice, like, cool person as a peach, a cool lady as a peach, right, maybe. And so maybe slightly more female. We'll get to, by the way, how the algorithm knows all these things. We'll get there in a second. And, you know, maybe as a result, slightly more human. Does everyone get the high-level idea here? Even if you disagree with the exact position the words are, does everyone see how this does exactly what Raphael was doing when he looked at the picture? It takes words that, in theory, the computer has no idea sort of, you know, what they are at a high level, and it basically puts them on this sort of number dimension, which tells you what words are closer to each other. Everyone see that? Now, the nice thing about it is, once you have this, suppose you tell ChatGPT, give me a synonym for woman. ChatGPT can do this very easily. It can just look at all the words that are close by, and it knows what the synonyms are. So that already gives you a high level, we're going to get into more depth, but a high level idea of what's going on here. Now, of course, the million-dollar question is, okay, this is nice, but I don't want to do this for every word in the English dictionary. How do we know where the words are here, what the scores are, where the words should be on the plot, right? It's a fair question. These, I just had 5 words and I put them on. In the English language, there's hundreds of thousands of words. How would I decide where to put them? And it turns out that no human decides this. How is it decided? Using good computer, bad computer. The computer does it automatically. But the question is, what does good computer, bad computer mean when it comes to words? Well, it turns out it uses a principle which is summarized as, you shall know a word by the company it keeps. Amazing that this was said by someone who, you know, passed away in 1960, way before this all happened. But this principle, you shall know a word by the company it keeps, is absolutely central, absolutely key to how this all works. What does a company like OpenAI do? They literally take all of the internet, and when I say literally, I mean literally, not figuratively. They will go out there, every page on the internet, Wikipedia, Reddit, Twitter, all that stuff. By the way, all kinds of legal implications there that I won't have time to get into. In any case, I'm not fully an expert on, but I'm sure you've all heard there's certainly been some questions as to whether they should be using all the internet to train their models. But let's put that aside for a second. And then what do? They say, well, listen, when we look at text, it looks like the word for lady and woman are used similarly in all the text on the internet, whereas it looks like the words for woman and apple are actually used very not similarly. And then what do? They start with a completely random embedding. So they start with a completely random embedding. They look at it, and they actually calculate the distance between all the words. How do they calculate that distance? Using Pythagoras' theorem. All of you now owe an apology to your high school math teachers when you were like, why would I ever use this in real life? Guess what? You've used it just now. So they're going to find the distance between the words, and they're going to say, okay, look at all the text on the internet. Do words like being and peach appear in the same context? If yes, good computer. If no, bad computer. And then they just start with a totally random embedding. They jiggle them a little bit. See, does it make better? Does it make the whole thing better? Do the distances match real life better? If yes, keep on going in that direction. If no, jiggle in a different direction. And just keep on going and going and going and going. And eventually, you get an embedding. Questions? Now, one quick downside, yeah? 100%. 100%. The AI is going, and in case people didn't hear that, the question was, is that why AI has bias? All AI is doing, I like to compare AI, I think a very good comparison, for all kinds of reasons, is a child that is sort of, maybe has just learned how to speak. And you know how sometimes a child will say a very uncomfortable truth. They'll say something, and you're like, oh, yeah. All they've done is repeated what they heard. There's nothing sort of particularly, right? They didn't make it up in some sense, just like the AI. And so because, unfortunately, the internet today is not a very pleasant place necessarily for everyone, all kinds of racist stuff, sexist stuff, all kinds of things you see out there on the internet, all the model is going to do is it's going to see, okay, what are the words that are close to each other, right? And so it results in all kinds of horrors where the model just learns effectively what it sees on the internet, which may not be what we really wanted to learn. I wish, again, I had 12 hours with you. Fascinating field of how they get around that, right? If you go to ChatGPT right now and you ask it to be sexist or to be racist or to be anti-Semitic, it won't do it. It'll tell you, I'm sorry, this is inappropriate, I can't sort of fill that request. How does it do it? Alas, no time today, but it's a great point. Good, yeah. No, so that's a great question. What's the difference between OpenAI's AI, between Llama's AI, between, you hear of all these different models, OpenAI, the Meta, the Anthropic, why do they all give different models? Again, I wish I had more time. I promise we do. Maybe you should all come back and take BA3. This is the new, now we don't just have BA1, which many of you took. We don't just have BA2, we have BA3. It's really, the universe is expanding. Anyway, but yes, excellent question, right? How do you get different models from different companies? At a high level, do you remember I showed you those billions of linear regressions that connect into each other? They're just different connections, basically. That's sort of a high level. If you'll forgive me, I just want to move up because we're going to do a really cool exercise in a second. So I want to sort of show it to you, and then I'll come back to questions. Good. Now, just one thing I want to note about this is that in reality, as I said, we don't just do this in 2 dimensions, right? Every word doesn't just get 2 numbers, it actually gets thousands of numbers. And so this all happens in a very high dimensional space that gives me a headache every time I try to think about it. The reason why it's relevant for our discussion today is the fact that it happens in such a high dimensional space means that you don't usually know what these axes are. So you remember on the previous slide I said the x-axis is male versus female, the y-axis is human versus non-human. In real life, you don't know what these actually mean, right? You can't go to OpenAI and to ChatGPT and say, oh, what is the essence of this word? All it'll tell you is, here are 1,000 numbers. This is the essence of these words, right? How it uses it, though, is what we're going to show you next. Okay, what I want to demo is a version of this that happened in 2013, so one of the earliest versions of this kind of work, right? At this point, 11 years ago. The nice thing about this is that it's going to be simple enough for us to demo in Excel. This was an algorithm called Word2Vec that was trained by a team at Google using the Google News corpus. So they looked at all of Google News, and they said, can we look at how words occur next to each other in Google News to figure out what the essence of a word should be? And we're going to look at it together right now. So let me show you the Excel spreadsheet I have. Quick advance warning. There's going to be a bunch of numbers on the Excel spreadsheet. Do not, I repeat, do not try to just take it all in at once. Be guided by me. I'm going to say, look at this cell, then look at this cell. Again, offline, I'm happy to discuss it in great detail. This is a spreadsheet I take maybe an hour and a half to cover in class. So we're only going to have 3 minutes together. But if you stick with me, you're going to see really, really amazing stuff come out of it. So don't be intimidated just by the spreadsheet as I put it up. Let's see, this is the one. We're going to do this and this. Okay, beautiful. So how does this spreadsheet work? I know, I told you, a lot of numbers, a lot of numbers. But hey, we're doing AI. This is the Instagram shot. You can be like, doing AI at Columbia Business School. There's lots of numbers. Look at that. Okay. That's why it's here. So what is this spreadsheet? First of all, this spreadsheet has 100,000 rows. Each one of those 100,000 rows is one word that occurs somewhere on the internet. So let's have a look at the kind of words we have. We have words like in, for, that, is, on, the. Let's scroll down a little bit. Let's see. Today, same, public, run, Friday. Every word that appears on the internet. Now, FYI, the real Word2Vec has 2 million words, but I'd rather not be fired as I crash these computers, so I narrowed it down to 100,000, just so we can actually get the Excel to sort of work without crashing on us. But this is 100,000 of the most common words on the internet. And then for each word, we have 300 numbers, so 300 columns, 0 to 299. What are these columns? These are the magical numbers that I told you about. This is what Word2Vec thinks is the essence of these words. So when you ask Word2Vec, when you ask this AI, what is the essence of the word in? It'll come back and tell you, aha, the essence of, so Raphael would say, well, the essence of the word in is it's a preposition that can occur in blah, blah. The model says the essence of the word in is 0.02665, 0.045614. That's what the model thinks the essence is. Okay. Now you might look at this and think, all right, who cares? Right? I mean, how does this lead to ChatGPT? Let me show you. On the next sheet, I'm going to show you, again, lots of cells. Don't be intimidated. Stick with me. I'm going to show you a spreadsheet where what I can do is I can put one word over here, and then what's going to happen is, right down here, the top 20 words are going to unfold that are the closest to that word according to Word2Vec. Is everyone with me? So I'm going to put in a word, and then it's going to say, looking at this 300-dimensional space, doing Pythagoras' theorem in 300 dimensions, what are the closest, most similar words according to Word2Vec? Is everyone with me? Let's find out. So I'm going to start with a word that I promise you, I planned this. This is in my lecture notes. You can ask. I've been doing it for a year. A little topical. I'm going to start with Trump as the word I put here. But I promise you, this is not chosen in any way. Let's have a look. And by the way, remember, this was trained in 2013 on the Google News corpus. Let's see what the closest words to Trump are in the Word2Vec dataset. And I can't emphasize enough, there is no magic happening here. All that is happening is Pythagoras' theorem in 300 dimensions. So every one of the 100,000 words is saying, how close is this one to Trump? How close is this one to Trump? How close is this one to Trump? Let's have a look. What are the top words that are closest to Trump? Trump, Trumps, Palin, Clintons, Ivanka, Hillary, Trump, Giuliani, Limbaugh, Hilton, Cavuto, McCain. Absolutely astonishing. So just because those words appear in similar contexts on the internet, it's figured out. Those words are sort of similar. The computer has started to think like a human. Instead of just seeing the word as a collection of letters, it sees it as a concept. Let's do one other example. The other one I had here was Cornell. There's a reason I'm not doing Columbia, by the way, which I'll get to. The problem with Columbia is that it's far too common a word. It refers to a lot of things, and so you just end up with a bit of a mishmash. Cornell, Yale, Bucknell, Hofstra, Hartwig, Vassar, Drexel, Colgate, Skidmore. Again, all colleges. So it's identified what those mean. Someone else give me one last example I'll put in there, and this is unplanned, so I didn't plant anyone in the audience. Does anyone want to give me a word you want to have a look at and what the closest ones are? Yeah. No, you know what? Someone said guilty. Here's the thing. Remember, this model was trained on Google News when? In 2013. We ain't going to see anything there. I mean, maybe you remember 2013, but there was a hand. I'm sorry. Yes. Intelligence. Let's find out. What are words that are closest to intelligence in Word2Vec? Now, this happens once in a while. The Excel's just crashing a little bit. It's okay. It'll wake up again. This is like, by the way, a 300 megabyte Excel file. It's, you know, we can give the computer a little break. It takes a little time to wake up sometimes. So we'll try intelligence in a second. There we are. Intelligence. Intelligence, counterintelligence, CIA, counterterrorism, counterterror, Mossad, DNI, counterterrorist, declassified, Panetta, who was probably in the news in relation to intelligence back in 2013. Okay, if you thought that was cool, It's about to get way cooler. It turns out that with Word2Vec, you can look at the closest word, but you can do something even better, which is to start doing word arithmetic. And let me show you what that means. Suppose you have 4 words in, again, I'm going back to a 2-dimensional embedding, just to be able to show it to you on the slide. King, man, queen, woman. You can start doing arithmetic. So for example, if I try and do king minus man, what is going to happen? Well, I'm going to take man, and I'm going to find minus man by just reversing the arrow. Then I'm going to take the man arrow and put it at the end of the king arrow, and that's going to be king minus man. And then I can add woman. So I can take the woman arrow and add it to this result, and I should get queen, right? Who's ready to see if that actually happens? Let's give it a try. So I'm going to go to my Excel again. I'm going to do king, man, woman, and I'm going to put a -1 next to man. Whoa. Nothing like doing Excel in front of a crowded room. I'm going to put a -1 in front of man and a 1 in front of woman. So this is going to do king plus king minus man plus woman. Closest word, queen. Insane. Let's show you another example. I have a few favorites here. Let's do Obama, remember 2013, minus America plus France. What do you think we'll get? Some French politicians. Let's see. Someone said Macron, but Macron was not on the scene back then. Sarkozy, Chirac, Fillon, Juppé. These are all, I'm French, by the way, so that's why I picked the... Okay, here's another really favorite one. What if I do baguette minus France plus Italy? Any thoughts? Let's have a look. One of the top results is focaccia. I cannot emphasize, you should all be falling off your chairs right now. This is not, and the reason I love this exercise is because the problem with something like ChatGPT, I do explain it eventually in class, but it takes like 12 hours. There's a lot that goes into ChatGPT. This is nothing. This is Pythagoras' theorem. And yet, just using those 300-dimensional sort of representations of words, it's able to extract this astonishing meaning out of the words. I think I have one more example that I really liked to show you how it can even understand things like grammar. Let's try and do walking minus walk plus eat. What do you think the result's going to be? Walking minus walk plus eat. Eating. Very good. Top word, eating. What has happened? It has realized that the difference between walking and walk is gerund to infinitive, I think. I'm not very good at grammar, but you get the idea, right? A word that is kind of the action word compared to the infinitive. And then it's basically asking itself, okay, so what is the equivalent gerund of eat? And it gives you eating. It's just crazy. Here's just one last one, which is also super, super cool. If you do Austin, let me hide the results again. Austin minus Texas plus California. Any guesses? Let's see. It knows geography. Sacramento. Austin is the capital of Texas. Sacramento is the capital of California. Astonishing. Astonishing. Truly. Let's see. What time do I have? Oh my goodness. There is a third tab that's even cooler, but it'll have to be for another day. Maybe at the end. If we have time, in the Q&A you can ask me. I do want to move on because, guess what? This is only 2013. We're still missing the final key that makes ChatGPT a thing. Okay, maybe one quick question at this point we have time for? Yeah. Well, it wouldn't. Even with the same number. No, with the same. If you put the same numbers in front of them, it wouldn't change. But if you can think of ways of doing the sum differently that are going to lead to subtly different results. I mean, another example that I sometimes show in class is the word mouse. If you look at the closest words, you'll see two very different kinds of words. You're going to see things like bat, critter, parasite, and you're going to see joystick, keyboard, right? Those words are all going to be close to mouse because they just appear in both those contexts on the internet, right? Really, really quite cool. Okay. Let me move on to the final kind of plank I promised today, and then I'll go to Q&A. And that is transformers. By the way, I have a theory. All these models, the more recent ones, they're all called like Transformers, Bert, Elmo, all these like sort of cartoon, whatever, the models. I don't know, maybe maybe computer scientists, maybe we weren't allowed to play with toys as kids, and so now we have to make up for it. I don't know, I'm only hypothesizing. Okay, so Transformers is absolutely transformational, maybe aptly named. They are the technique that made ChatGPT. These were invented in 2017 by a team at Google, and they basically revolutionized absolutely everything we do with text. Transformers fix one key problem with Word2Vec, with the embeddings we saw earlier, and the more eagle-eyed among you may have already spotted it. And to show you that difference, consider these two sentences. The monkey ate the banana because it was hungry, and the monkey ate the banana because it was yummy. Now, as humans, instantly we know that this it refers to what? The monkey, because the monkey was hungry. And this it refers to what? The banana, because it was yummy. By the way, English is hard. I don't know what to tell you, but like, you know, the fact you're just supposed to know this from context cues is really quite difficult. How is a computer supposed to know this? The problem with Word2Vec is that if I take the word it and I ask Word2Vec, okay, what is the 300-dimensional sort of representation of it? It's going to be the same in both cases. It's not going to be able to distinguish this it from this it, because it only uses the word itself, right? The word it is the word it wherever it appears. Transformers change that. And let me give you an example of how they change it. Here is an actual example from Google. Suppose you Google 2019 Brazil traveler to USA need a visa. What are you referring to? Any guesses? As a human, what do you look at this? And it's obviously referring to what? Good, you're a Brazilian person. You want to go to the USA. As someone who has Brazilian citizenship, do I need a visa to get into the USA? Pre-Transformers, this was the top Google search result. US citizens can travel to Brazil without the red tape of a visa. Because all Google did is it looked at it, it said, I see USA, I see Brazil, I have to make an educated guess, right? I can't relate them to each other. Post-Transformers, Google search will give you 2 reasons to visit a US embassy and consulates in Brazil, because it knows that traveler refers to Brazil and not to USA because of Transformers. Is everyone with me? Now, leads to the question, how do Transformers work? Transformers work in a fiendishly clever way. How do they do it? They simply take, oh, this is the paper, by the way, from Google. I always like to show this paper because if you look at the footnotes of the authors, this one, there's a footnote next to every author has a star. It says, equal contribution, listing order is random. Everyone refers to this paper as Vaswani et al. It was Vaswani's luckiest day. Like, I mean, everyone knows Transformers is Vaswani et al. When really it was all these people who should all absolutely get credit. And so that's why I like to show this, this paper up here. So this was a 2017 paper. And so how does it do it? It's really quite simple. It begins with a simple embedding. So this is what the embedding of what the word it might be. And then it says, let me sniff around the sentence and let me see if I can find other words that should affect that embedding. And so hopefully what would happen is that in the first sentence, the transformer will nudge it towards monkey because it realizes that the words around it imply that it refers to a monkey. And in the second sentence, it would nudge the embedding of it towards banana. So it would make it slightly closer to banana. Now again, how it does that, mathematically, how it works, etc. I'm being told I have 5 minutes left. Alas, we ain't gonna be able to talk about today. But that's all that happens. It just tweaks those numbers a teensy bit to get the new position, the new embedding of that word. Questions? Yeah.
If they're fed globally, right, information globally, just like the internet, how does it control for different ways of saying things, different languages?
Excellent. We're going to answer this in a second.
Cultural,
I'm going to show you another demo that's going to story. Basically, they learn about humans. They use all the language on the internet to learn. Just if you have text on the internet in, I don't know, French, it learns French. If you have text on the internet in a culture that is different to the US in terms of how it treats certain things, it'll learn that too, by going through all this data and sort of crunching it. And again, I wish I could go into more detail into how it does it, but effectively what it does is it figures out, for example, this word is English, and so when this word soaks up the meaning of the words around it, it should use the English transformer. If the word, let's say, it was in Arabic, then when it soaks up the words around it, it uses, so that's kind of the high-level idea of how it works. Okay, last thing I want to do, two things left. One is I want to tell you how this leads to ChatGPT. And by the way, you know everything you need for ChatGPT. There's only one tiny last step. And then I want to show you another demo that I think you'll find a lot of fun. Okay, so how does this work for ChatGPT? Well, the key thing to realize, which makes transformers amazing, is because every word pays attention to every other word in the sentence. What does that mean? That means that that last word, when you find the transformer embedding of that last word, it kind of soaks up the entire sentence. It includes the entire sentence. Just like if I look at any one of you in this room today, you are the product of your entire life. And so by looking at you today, I can say a lot of things about your entire life. Similarly, if you look at the embedding of the last word, you can say a lot about the entire sentence. All ChatGPT does, and again, this is a very high level, is it looks at the embedding of the last word in your question, which includes the whole question, and it says, all right, what's the closest next word? And what's the closest next word? And what's the closest next word that I should be generating to produce an answer? And so at a high level, all ChatGPT is doing is suppose you put in a sentence, it was the best of times, it was the blank, and you tell ChatGPT, please fill this out. What does it do? It says, let me look at all the other words in the English language and figure out which one seems to be closest in some sense to that word, and that's the word it guesses next. Okay, so worst, the opening of Charles Dickens. If anyone's A Tale of Two Cities by Charles Dickens. It was the best of times, it was the worst of times. Then it does it again, and it does it again, and it does it again, etc. And that's pretty much at a high level how ChatGPT works. Okay, the very last thing I want to do, I have 2 minutes left. Maybe if you will forgive me, I'll maybe encroach 1 minute into the question time because this is a really, really cool demo. When I teach this in my BA2 class, and some of you may have actually taken BA2 with me, maybe, and if you did, you'll remember at the start of class, I ask you to provide me with a book, a movie, or a restaurant review that I can use for analytics. Just so everyone knows, ever since I started teaching the class, I've always put in the pre-class quiz that those might be shared publicly, so I'm not using students' data without their permission, it's their reviews, but I've had everyone's consent, and they have the option not to fill out the review that they don't want to, so I'm not stealing students' data here for my presentation. And so what I'm going to pull up is those reviews, and again, lots of cells here. Focus on what I'm going to show you. So for example here, we have a list of reviews. These were the students who took BA2 this summer, so 157 of them. And we can look at the reviews. So for example, we have something like, I've been meaning to dine at Becco and Hell's Kitchen again because it was an exceptional experience, or you can eat pasta, right? You get these kinds of reviews. What I'm going to show you, which is again a truly astonishing use of these models, I'm going to put in a bunch of queries into the model. Let me explain what that means. So let's say, let me take an interesting one. A good interesting one is maybe query number 2. Yeah, rancid food. Okay. So I take the sentence, rancid food. And then what do? I put it through a transformer, and I ask the transformer, all right, rancid food. What is your essence? What is the essence of those words? Notice that because I now use transformers, it's not the essence of just one word, it's the essence of the whole expression, the whole sentence. Okay, and that's what I get underneath. So the query embedding is going to be this very big, I think it's, how many numbers? 1,536 numbers. So a lot of essences. And then what am I going to do? Get ready, you're going to fall off your chairs, just hold on. I'm going to take all the reviews that the students wrote, and I'm going to find the embedding of those reviews. And I'm going to say, what are the reviews with the closest embeddings to the embedding for rancid food? Let's have a look at what reviews pop up. Let's see. All right. Dreary, dreadful, disgusting. These would all be compliments to the rat-infected Brooklyn diner at LaGuardia Airport. Good. May God have mercy on my soul and my stomach. Next one. I can't believe Lautusi had a Michelin star recommendation. I can't know the cacio e pepe, blah, blah, blah. After a single bite of the fresh strawberry, I knew something was wrong. Could barely finish it. Had to be the culprit. I had food poisoning. Guys, does the word rancid appear anywhere here? Does the word food? I guess there is the word food. The word rancid doesn't appear in the review. And yet the transformer has figured out that's got a whiff of rancid. And so the embeddings are close to each other. Does that make sense? To get to your question, I want to show you one thing, which is another really cool query. I have a query here. This one, again, is going to just amaze you. Which one was it? Nope. This is really cool. You actually get creative desserts, even though it doesn't have the words creative. Tearjerker is cool as well. This one. You asked about different languages. Here is a query. Un film qui m'a rappelé mon enfance. French for a movie that reminded me of my childhood. Notice how there are accents, right? I mean, it's not quite a different alphabet, but it's, there are different letters than you might expect in English. Again, I find the embedding of this sentence in French, and then I see which of the English reviews are closest to that French embedding. Let's have a look. Top one. Turning Red is a delightful and heartwarming film that beautifully captures the challenges and joys of growing up. Harry Potter has been an all-time favorite since childhood. The plot is so engaging, astonishing, right? It's found reviews that have a vibe of childhood. Okay? One last one, because I just can't resist. This is like even cooler. This is crazy. The query number 6 is just the shrug emoji. Now, you might think, how does the model know what the shrug emoji is? Guess what? Because it was trained on all the internet. And what appears on all the internet? The shrug emoji. Let's see what reviews have their embeddings closest to the shrug emoji. Top review. It really looks delicious, seriously sumptuous, and then you sit down and wow, it's just so wondrously overrated. So it seems to be this ambivalent review. Avatar impresses with stunning visual effects, beautifully realized world of Pandora. However, while visually striking, lacked the development needed to engage in the audience. So it's giving you ambivalence as a result of that emoji. Again, just astonishing. And again, all we're doing, I mean, the transformer is quite complicated to get those 1,500 numbers, but then we're just finding how similar these embeddings are. I have like truly so much more to talk about, but I'm going to be shot, I think, if I don't, well, metaphorically, if I don't stop. So I'm going to stop here. So much more. I hope at least you get, hopefully now when you use ChatGPT, at least you get a rough idea that all that's going on under the hood is just these agglomeration of numbers with these many stacked models, trying to find closest words, having the model, the computer kind of understand what the essence of the words are. And that's really all that's happening under the hood with these models. So I'll stop here and take questions. Should I pick them, or do one of you want to? I'll take them as I see them. Yes, please. Yeah. So question on terminology. Can predictive analytics and generative AI be used interchangeably? What I tell at the start of every class to all my students is, all these terms, predictive analytics, business analytics, AI, Gen AI, etc. I'll answer your question directly in a second, but all these terms, there is no central body that, is the king of everything and defines what they are. And so generally, there's a lot of overlap between what people mean when they refer to them. And so you should definitely ask people to clarify. But in terms of what you should use, I always tell people, if you're giving a presentation, use them all one after the other. When the audience's eyes light up, that's the one you stick with for the rest of the talk, because it's going to work pretty well. To your question specifically, Gen AI is generally used when you are generating new content. Predictive analytics is when you're trying to predict something. But as we just saw, the Gen AI like ChatGPT, what is it doing? It's just predicting the next word. And so there's a lot of overlap. But generally, the way I've seen it used, Gen AI is when you're generating things. Predictive analytics is when you're just making a prediction without a sort of creative generation process. But it's very subjective, which is which. I saw one at the back. Yes.
Great presentation, by the way. I really appreciate it. Talk to me a little bit about sustainability and this, because this takes a lot of computing power.
Crazy.
And between this, blockchain, crypto, it seems like we're undermining, any kind of sustainability issues.
Massive topic here in terms of, this is not sustainable. This takes a tremendous amount of energy to train. I would put it in a different class than crypto, than blockchain. Crypto, I would say, is much worse for reasons we can talk about offline, but just in terms of the sheer amount of carbon dioxide produced, crypto is worse. Also with crypto, the way crypto is designed, and again, if we had another hour, I'd go into the mechanics of crypto. Crypto is basically, at least Bitcoin, is designed so that the amount of money you get is directly proportional to the amount of energy you expend. And so the more energy you expend, the more money you get. This is not necessarily true with these models, right? There's a real incentive, and there's a lot of research going on right now on how can we take these models and make them smaller while still retaining their intelligence. So just one example, I don't know if anyone has used ChatGPT 4.0, it's the latest model by OpenAI. One thing you will immediately notice when you try to use it is it's much snappier, much faster. It just gives you responses much quicker. Why is that? Because they managed to create a much smaller model, which therefore uses much less energy to train. So I'm hopeful that the state we are at right now in terms of how polluting and how energy intensive these models are is somewhat transient until we make them better. It doesn't reduce the fact that they certainly do produce an enormous footprint. Especially whenever I speak to the companies, I consult with a bunch of companies. I'm lucky enough to be on a few boards. As soon as all this stuff came out, everyone just is like, okay, how do we use generative AI? That's the next meeting. That's the only topic in the meeting. And what I sometimes tell them is, wait, there's all this other stuff that works really well. Why would you use something that is incredibly energy intensive, incredibly complex, incredibly difficult to implement when you could just use some of the more basic stuff? So I think we're going to reach an equilibrium where the hype is going to, we're going to realize these models are incredibly powerful. They're good for some things like unstructured data, but then we might also complement them with more basic models that are much less energy intensive. I'm not sure if that fully answers the question, but I hope it helps at least a little bit. Yes?
Should generative AI be regulated, and what would be your advice to the government?
Should generative AI be regulated, and what would be my advice? I have opinions. I do not think that, with some exceptions, but at a high level, I don't think I'm any more qualified than any of you in terms of opining on that. I know how the models work really well, and so I might be better qualified at opining on the exact way the regulation should be worded. But I think part of the problem with the way this conversation is going on is it's being left to the people who know how these models work, people like me. They're not necessarily representative of the whole population, right? I don't think, right? And so I think I'm not going to opine on it directly on any specific details because I think arguably that's part of the problem. My opinion is interesting. We'll definitely talk about it offline, happy to, but it's not, I think, one that I'm qualified to stand in front of a room and tell you sort of this is gospel. But I think it's fair to say there's going to have to be some regulation. I don't think that's controversial, right? Just given how powerful the technology is, the question of exactly where it is and what it is, let me just put it this way. I think it is hard enough to get a room of 100 random Americans to agree on whether a headline is fake news or not fake news. Given that environment, the hope that we can somehow come up with a unified piece of regulation that can define what that means when it comes to what AI generates is really quite challenging. But we gotta make it happen. It's really powerful technology. Yes, you have your hand up for a while.
Two, like how does prescriptive analytics work by leveraging mathematical optimization?
Excellent question.
Can you explain it in just like ChatGPT in a couple of minutes?
Let me ask ChatGPT. The question was about prescriptive analytics, right? Predictive analytics makes a prediction. For example, what is the probability that I will default on a credit card if the bank gives it to me? Prescriptive analytics is about, okay, what do I do with that information? Very, very complex topic. There's no, again, how do I describe it at a sort of high level? I think part of the reason, I'll give you at a high level, the reason, I mean, fundamentally your question is, at a high level, why can I not just act on the predictions, right? If predictive analytics says, Joseph will be a great credit card holder, he's not going to default, why not just give him a credit card? Why would I sometimes do something different? At a high level, part of the reason is because these things are not divorced. The AI is part of a broader system. And if I just use the model, the prediction, to make decisions, that's going to change the world in some way. And then that's going to feed back into the model, and it's going to lead to all these sort of perhaps unexpected and unwanted feedback loops. And so that's why you have to be a lot more careful. Prescriptive analytics is hard, really, really hard to get right. But that's at a high level why it's such a challenging field. You're going to stop me 5 minutes? Okay, great. So we have time for some more. Yeah. How will faster computers or quantum computing change this? That is a great question. I was lucky enough to moderate a panel at the CBS India conference. It was a panel with the CEO of IBM who was on the panel. And I asked him, what is the most exciting technology for you, sort of, in the next few years? Quantum computing was very much what he highlighted. He's also a very interesting CEO. He's the first CEO of IBM, as far as I know, that came up through the research, IBM research, rather than through the business side. So, he would know. He's very, previous CEOs were also very smart, but he's really sort of into the engineering details. The answer is we don't know. At a high level, it's going to make these models much, much easier, much faster to train. That's definitely going to be the case. Now, what we don't know at this point is, and I cannot emphasize how new this field is in terms of the research we're doing on it. We don't know whether more training will be helpful, right? I mean, there's a point at which you get diminishing returns. We haven't reached it yet, I think it's fair to say. But how will faster computing really make a difference? It's kind of very, very hard to predict. I will also say that for all you hear about quantum computing, it is a very exciting technology. Just think of the first airplanes produced. That is what we're going to get when quantum computing becomes real. It's going to be awesome. It's not going to be, you're not going to have a quantum iPhone, anytime soon. And so I think for it to actually affect the most advanced kind of computing like this, I think it might be a while. But people are ready for it, right? A lot of cryptography on the internet, a lot of the things that secure communications on the internet are already moving to algorithms that are secure to quantum attacks, to quantum computers, because people are worried the old algorithms for cryptography we were using 10, 15 years ago could easily be cracked by a quantum computer. Yes, at the back.
Rather than generative AI.
Yeah. So can I speak to some of the easier to implement solutions in generative AI? So the more classical machine learning stuff, short answer is any situation where you have an Excel table with a bunch of columns about someone being the data and then an output you want to predict, unlikely you need generative AI. And that spans an enormous range of examples. I mean, think of any application that is really sort of impactful today in terms of AI, predicting defaults, predicting if someone's going to click on an ad, predicting whether someone's going to cancel their contract, predicting whether someone will respond to a particular mailing, predicting whether, we had this project when I was at Palantir where there's a utility company that was trying, this is actually a hilarious story, a utility company was trying to predict, I don't know if I can, you won't tell anyone. A utility company was trying to predict what air conditioning units were going to break down soonest so they could send people to do preventative maintenance. Someone, not a Palantir, but someone made a slight mistake and they sorted them ascending instead of descending. And so instead of sending technicians to the units that were most likely to break, they sent engineers to the units least likely to break. And so you had technicians knocking on doors of people who had their units installed yesterday. And they were like, hey, we're here to do preventative maintenance on your unit. And they were like, what? But anyway, that's another example, right? So there's really a lot you can do with sort of classical data. The only place where these more advanced models might be needed is unstructured data, video, text, images that just don't fit in a table. I'm ending? Okay. It has been such a joy, such a pleasure. Thank you so much for having me.